right, we might as well go ahead and get started. And part of me, I don't know about you guys, but I'm looking to beat the rain. So if we can somehow do that, that would be great. So my name is Jennifer Krueger, and I have been with the CCTS for a couple of years. I have the privilege of working with investigators as part of our CCTS Research Commons. But really, that is code for bringing people together and making connections. Building bridges, it's not even bridges, it's bringing people and establishing relationships to advance our scientific goals. And we all know that by working together, we can be infinitely more successful than working by ourselves. And so I think that you're gonna find that as a common theme in a lot of the things that we talk about this afternoon. So I get to talk about something that we affectionately call panels here in the CCTS. And I'm going to actually start by asking a somewhat tangential question. Does anybody in here like ice cream? So I'm seeing a couple hands go up. I love ice cream. I don't go to bed without having had ice cream beforehand. So I guess I assume that we all like all the flavors all of the time. Or is it possible that you might like vanilla better than chocolate? Any chocolate fans? A lot of chocolate fans. Vanilla fans? I think I've just covered the majority of people. Are there any people that did not raise their hand for vanilla or chocolate? Yes, absolutely. Right? So we all have, things that we like, different varieties of ice cream that we tend to like. I think that I'd like to just kind of draw the parallel then to our panels program. The CCTS conducts panels, and generally speaking, this is our opportunity to bring investigators together to help provide an edge to a given scientific idea and make it more competitive or more commercializable or more likely to advance, more likely to connect and be translated across a translational spectrum. But we do this in a variety of different ways. So for example, some investigators, such as you might have a proposal where you haven't even conceptualized your specific aims yet. You've got an idea, you've recognized a gap in the scientific literature, so you're very nascent in the development of your scientific premise. And so the CCTS has a venue called the Nascent Project Panels, where we bring investigators very early on in their project development to speak with a multidisciplinary group of investigators who can kind of help you brainstorm some ideas. And it's actually a whole lot of fun because we have so many different disciplines around the table that you really can get some very out-of-the-box kind of thinking. And that's the kind of edge that we think can make a very big difference. But the very nice thing about the NPP, if you will, is that it's early enough along in your process that you have the agility to kind of flex and do things differently, or you can do a couple of additional experiments that might be prompted by the discussion. So some of you might be at that stage. Some of you actually might be targeting an R01 deadline in October. And the great news is it's only July. The bad news is it's already July. So we, the CCTS, recognizes that maybe that's a little too close for comfort to have this kind of broad-ranging nascent project panel. And so we've created something that we affectionately call Panels Done Quickly. And this is something that we can turn around in usually about a week. If you, as an investigator, call us and say, I'd really love to have a PDQ, we'd be very happy to work with you and find some people to come around a table that will provide some feedback on your proposal. At that stage, you probably have your specific aims well written. You probably have your research strategy pretty well along, but it might not be finalized yet. So I've just given you vanilla and I've given you chocolate, some of the kind of fundamental panels that we like to conduct here in the CCTS. But we have not stopped there because, of course, we recognized in our poll there's also some very special kinds of ice cream or kinds of panels that we think can make a difference in clinical and translational research. And so some of these involve bringing investigators from clinical disciplines together with bench scientists to think through how to understand, for example, a biologic mechanism that might relate to a clinical observation that's occurring in a certain patient population. Maybe you have a device that you would like to develop and you'd like to understand the strategies on how to take that device and translate it to the commercial marketplace. So we have a panel called iPanels or innovation panels that is structured to try and bring the right people around the table to have the right kind of conversation that you're looking for. And so I don't have a slide today, but rather I want to encourage everyone to go to our website, uab.edu/CCTS, and you can learn all about the different kinds of panels that we have. But really, at the core of everything, I want you to come away from today as maybe a panel could bring some value to my work or to your work. And so you might ask me, what difference does it make? Does anyone care? Does it actually make a difference in the scientific success? And so I thought I might give a couple of statistics on how we've observed this program over time. And I'm delighted that our colleague, Dr. Tom Harris, will also be able to tell us a little bit about his experience. So over the past couple of years, we have been able to engage over 700 investigators from UAB and from across our partner network in panels. So that's non-trivial. That's a few more than can fit in this room, but it's really a remarkable engagement. People are joining us not because they're paid to, but because they want to, because they believe it makes a difference. So you might also ask me, well, what difference does it make? So I'll turn the question around and ask, what is the current NIH pay line? Generally speaking, for the institutes that you're most interested in sending applications to, where are they making the cut these days?
18%.
18%. Okay, that's way better than it used to be. 9 or 10%. It used to be single digits, which was scary. So 18 is promising. If we kind of use the 10% bar, which might be pretty common across some of the major institutes, our panels program, the investigators that use our panels program to sharpen their science before they send their applications to a study section have about a 3 to 5 times greater likelihood of being funded 18 months out from that application. So that is a very significant difference. They are much more likely to get their grants by working together. And I thought maybe I would close before handing off the mic to Tom, in that one of the comments I made was the reviewers, the people that we bring to the table, are disciplinary experts in the content space that you'd like to work in. But it's also statisticians and methodologists. It's also informaticists. It's folks that may not have a direct relationship to your disciplinary expertise. And that's intentionally because study sections are not necessarily clones of you and your discipline. It's a variety of different backgrounds and expertise. And so we want to make sure that we bring all these kinds of viewpoints to the table to help you make the most competitive applications you possibly can. And these folks are not paid. These are your colleagues, they're your collaborators, they're the people across campus who, again, are just deeply indebted or deeply affected by the promise and the success of this program and their eagerness to be part of it. So I wanted to actually take this opportunity to recognize that we have several folks that really go above and beyond the call of duty And I wanted to personally thank and acknowledge here at the Hub over the past year, several of our colleagues, including Gareth Dutton from the Department of Medicine, Steve Barnes, who wasn't able to make it today, from the Department of Pharmacology and Toxicology, Dr. Froelich from Anesthesiology, Dr. Bedwell from Biochemistry, and Allison Hall from the Health Services Administration. These folks have really been genuine partners in this process, and it's a real delight to work with them. And so we will hopefully be delivering a token of our appreciation over the next couple of days to reflect that kind service. But I'd also like to acknowledge Rita Cowell from Southern Research, John Lafont from Tulane University, Robert Arnold from Auburn University, and Mark Gillespie from University of South Alabama. So this is a CCTS partner network. We work with 11 institutions, and we have investigators from all of these partners who are also coming to the table to help us all put forth our best science. And so we also are happy to acknowledge their efforts. So before I hand it off, from a general point of view of what panels are there any questions about anything I've just described?
Jennifer, how does one go about setting up a panel or requesting a panel?
Thank you very much for that question. So I've talked a little bit about the variety of things. If you are interested in learning more or asking and requesting a panel, all you have to do is email or call the CCTS and say, I'd like a panel, and we can do the rest. And so you don't have to figure out who to bring to the table. You don't have to figure out all of the details and nuance. We will partner with you to make it happen. You guys get to do the science. You get to do what you're good at. And so just give us a call and we'll make it happen. Are there any other questions? Well, if you don't mind, then I'd like to take this opportunity to invite Dr. Harris up to the front to talk a little bit about his experience with the panels program. Thanks, Tom.
Great. Great. Well, thank you very much for inviting me here today to discuss how the CCTS panels have been supportive in my research efforts. And, I guess following the title, or the CCTS Runway to Success, I thought we'd talk about some, basically how to use these panels basically to get research careers off the ground. So I guess when we try to think about journeys and travel, probably the two really key questions are who are you and where do you want to go? So just a little introduction to myself. So I'm a pediatric pulmonologist, and I work in cystic fibrosis, and I'm specifically interested in modifiers of CF disease severity, and previously focused on TGF-beta associated remodeling, and then more recently I moved into microRNA target site blockade and how that helps CFTR modulation, and that's what the CCTS helped me basically build some of that foundation. So, as far as thinking about the destination, I thought I, again, would utilize upcoming this summer. I'm going to go see my wife's in-laws, or I guess my in-laws. Maybe that's a Freudian, right? In Belfast, Northern Ireland, right? And so, and I thought that might be a nice metaphor for the research journey as well, where in general, there's this general knowledge of how you might get from Birmingham, Alabama. And first of all, making sure it's Birmingham, Alabama rather than Birmingham, United Kingdom, and Birmingham's probably, much further away. And you have a general sense that it's a long way away and there's obstacles ahead of you, and generally utilize flight. And I think most folks probably have that as far as just research planning. But really, where the CCTS provides opportunity is through the pragmatics, that they've actually been there before. They kind of know what it takes. They understand the obstacles that perhaps you wouldn't think about, and they know what's really kind of expected of you. So, as again, I saw the title as far as the Runway to Success, and I found this picture on your website that kind of looked like a little bit of a broken down runway in some ways, this long table with us all sitting around, and we've all kind of sat at that table as well. And I actually had the privilege of having 3 panels that I utilized. So the first was the NASITS project panel, which is I was trying to kind of put together some ideas as far as my KO8. The second was you all have paperwork there for kind of the partner network project panel project, and I had a panel discussion about that, which in some ways is a lot like a PDQ panel. And then as I have been working on that partner network pilot and now progressing into a K, also kind of utilizing a project development team. So in some ways that is our 3 different flavors, or at least 3 different flavors of ice cream, right? You know, so we started out generic and now we've gone really kind of specific. So maybe Oreo was the last one. You know, so the first is again the nascent panels project. In a lot of ways, that's like preparing for takeoff, right? So you have a general sense of what you want to do, and in my case, I was trying to prepare for a KO8, and the KO8 has 2 major parts. One's career development, and one's actually the research science. And so I brought both of those to the nascent panels project panels. And in general, basically, and I like a lot of people, probably was just a little bit too broad. So I kind of came to it as like, I want to learn how to do CF drug development. Just things that they're good intentions, but basically they're not really going to kind of carry water. I want to basically take some of our in vitro results and translate them in vivo. I want to basically kind of learn how to do in vivo CFTR measurement. And I think in some ways you're going to learn how to do this, but you want to really kind of focus on that. And that was really the big field that came back to me. So basically narrow the focus. Folks are just going to be a little bit less interested in big, vague concepts that perhaps aren't really reasonable within in this case, a KO8 study period. So and to really kind of, as they heard what I was talking about, then kind of again focus that down to, let's really talk about, you're going to utilize this K for microRNA training and the science of microRNA and the mechanism of that. And also a pretty good piece of advice that, if you have that good scientific pursuit, in a lot of ways your career development plan will follow that. And then obviously really emphasizing local resources. But it doesn't mean you have to use all the local resources, but just identify the strengths of the local institution. So that obviously is very helpful, because I think a lot of times with a K, a lot of people focus so much on the scientific plan, you forget that it's really as a career development plan. So that's really helpful. And then again, from the scientific perspective, it was the same sort of thing. I probably was kind of just a little bit too big and vague, right? So I was kind of like, okay, how are we going to manipulate TGF-beta and CF? And if anybody's ever worked in that field, they know that's quicksand, and also, again, folks that, worked on TGF-beta for a long time. And so I had some vague aims, but again, the feedback was narrow the focus, and maybe instead of thinking all of TGF-beta, we had some interesting microRNA data, and so how is that going to be the mechanism? And again, how are we going to kind of learn that science? And so that's what it was, how microRNA affects kind of TGF-beta interaction with CFTR. So again, kind of made that plan a lot more linear. So I guess, so then the second interaction was with, as I prepared for the CTS, the partner network pilot, was again a little bit more specific, but then again this was very helpful for the K application as well. So by this time I had kind of narrowed things down to microRNA and had my 3 aims to that effect, which probably are too different from the K, but again the polish here was basically, okay, how is this novel? Like, again, even though microRNA are relatively new, how are you going to convince the reviewers that this is really a novel mechanism? And so instead of just saying I'm going to do microRNA, I kind of threw in a flavor of, we're going to really look at how this affects CFTR modulators, which are, coming on board and see it, but they're FDA approved, that were not really clinically effective. I think that was helpful. Think about how are you going to really look at that, the mechanism of interaction, and then very importantly, how is this going to advance your career? So I think that was very helpful. And I think with that feedback, as Dr. Krueger said, I think that really made, and really preparing for the pilot partner, or the partner pilot, really helped preparing for the KO8, a relatively straightforward process. And both the career development plan and the research plan were benefited by that preparation. And then the last panel that I have participated in or continue to participate in is really the project development teams. And in some ways, some of the previous panels, they're about the science, but there's a bit of a grantsmanship there, where the project development team, my experience has been a lot more, okay, how do we actually anticipate obstacles, and also how do we bring this to the next level? So obviously having a K now, the next question, well, how do you get an R from this? And so, a couple of feedback examples would be looking at basically, I think as far as the grant proposals, it was very much trying to take my previous in vitro data in vivo, just kind of develop how this might be a therapeutic modality, but a lot of emphasis on really focus on the mechanisms in vitro, and that will actually aid the in vivo work and save you a lot of time. I work with one specific microRNA, and just advice as far as make sure that even though we think we know what that's doing in humans, it may not be happening in rodents, and in fact that's true. And so basically looking at other microRNA within that, identifying which readout is best. So I started out thinking about, nasal PDs as a CFTR readout and really tracheal explants. And so these are kind of examples of how that feedback has helped guide me and really anticipate what's going to be my directions over the next several months, and been very helpful, and I'll continue to use them during the K period. So I guess, kind of an overview of that is, well, how is, what is the benefit of the CCTS support structure? And in a lot of ways, I feel like kind of they're, out in this research journal, they're offering you little, life rafts to kind of keep you afloat as you kind of reach one between and you think you can swim, and then it's helpful to have something else that kind of keeps you afloat. And again, I guess two feedbacks as far as the panel and the process is, the panel again is people participating on, they're very familiar with the NIH level expectations and how the proposals should be framed in that context. I really found the panel also to, they're coming prepared for a discussion. And it was really this nice blend of basically impartial. They're not folks who are on your scientific team. And that's really who the review committees are going to be. Very supportive. They all want you to succeed, but also this kind of healthy skepticism of, okay, how is this going to be reviewed? And that to me was very helpful. And obviously it's helpful when you know that the people who are talking to you have had their own personal success, and also the structure has also been successful. So those were some points there. And again, as Dr. Krueger said, the process is very streamlined. It literally is an email, and basically say, what do you want to talk about? The people who come to the table are ready for a discussion, and they're people that are familiar with the field, but then not just people that you've already maybe had some of these discussions with. And the staff is extremely supportive, and you get a summary statement at the end that you can continue to reference as time goes on. So, so that's kind of the journey. And I guess just from my own personal perspective, I guess I'd throw in the two things about recognizing that even though Google Maps may say there's a direct flight from Birmingham to Belfast, Northern Ireland, and you just kind of generally go there, the journey can be, you need a lot of different steps in that process. And so this is how I'm getting there. I'm taking the family in the minivan to Atlanta, and instead of flying Air Lingus, we're flying Air France because it was cheaper. And then from Dublin, we're going to take a bus up to Belfast where we'll rent an Airbnb, and that's kind of been the awards. But central to that awards is, again, that CCTS pilot partner network pilot was really helpful to kind of help me bridge, and again, be a little bit of that life raft as I was putting together the K award. And then again, there's other foundational support and pharmaceutical support. And I guess that's kind of another, I guess personal thing is just the mechanism of this journey is going to be a bit of, planes, trains, and automobiles, where you're going to have to, really be committed to the destination, right? And that's why, again, that first question, who are you? What do you want to do, and where do you want to go? To understand what are the complementary funding sources, both intramurally as well as extramurally. So within my world, that's CF Foundation, some pharmaceuticals, and obviously NIH. Having research teams that kind of have overlapping spheres. So I've done a lot of remodeling and microRNA affected that, but also then that reached over to CFTR modulation. So it's been helpful to kind of have within a couple of molecules overlapping effects, but also separate, and important to collaborate. So in my case, what we try to put forward was working with a CF rat, which is unique to this institution, but ultimately probably the better models might be a pig or a ferret that are institutions, and also as far as therapeutic interventions, maybe antisense oligonucleotides, and so reaching out to pharmaceutical companies that already have experience with that. So my review from the CCTS panel is, again, it's 5 stars. That's right. Exactly, 4.5. No. So again, it just really helped refine the focus, both with my own career development plan as well as the scientific plan. Helped organize it and just polish and say this is what will be better received. Give a perspective, and again, you can participate at whatever your stage is, and then again identified additional collaborators like Bill Gerthofer was a MIR 145 specialist down at USA that I had no idea was available. So I guess in conclusion, kind of enjoy your flight. CCTS support's beneficial at any stage. The infrastructure is truly outstanding. It's wonderful. The panel discussions really refine and mature our approaches, and then there's a wealth of experience just waiting to be tapped. And so again, acknowledging the team. This picture is dated by one game. This is the England guy, winning on penalty kicks in the, I guess was at the quarterfinals, and they lost today. But I'm really appreciative of the CCTS personnel. Gene and Angie have been patient with me. All these are actually, for my own panels, this is actually who's participated. So it gives you a sample of the array of people who are involved, and obviously funding support that's helped out, one of which is the CCTS pilot, which was really helpful. Great. Thanks for your time, and I welcome any questions.
Are there any questions for Tom?
Thank you.
So Tom mentions that, I don't know if I need a...
Yep. Sorry. Thank you.
Thank you. Tom had mentioned that one of the panels that he was able to leverage was related to his pilot program. And so a lot of you, perhaps if you didn't notice, because you sat down too quickly, there is a piece of paper on your chair that relates to a pilot RFA that launches today, right now. And we have the good Dr. Kent Kaiser, who's going to talk to us a little bit about the RFA. I'll hand it to Kent.
Thank you, Jennifer. So my name is Kent Pfizer. I'm a co-leader of the pilot program, CCTS, which I've been involved with the CCTS since the very beginning, the very first application that wasn't funded, and that was many years ago. I'm the last person standing, I think, from that cycle. So my initial involvement with the CCTS was through the panels program. And I've served on a number of panels over the years. And I have to say, they're fun. You meet people you wouldn't meet otherwise, you learn about science you wouldn't know about otherwise. It's a fantastic experience. And I just want to reinforce what Dr. Harris said. This is collegial. It's not a moment for a gotcha to try to embarrass you. We're all sort of on the same team. We want your science to be as strong as possible. We want you to be successful. So don't feel at all shy about asking for a panel. Now, the pilot program has been around for a number of years as well. And this is an important program. I just wanted to point out that on everybody's chair, there was this enormous packet, right? And it intentionally looks kind of like an NIH-style grant application. So don't be alarmed, don't be put off. I've distilled it down to a few bullets over about a page. To be successful, okay, I'm going to tell you, you will be in control of your fate. To be successful in this pilot application, should you choose to submit, make sure you're responsive to the RFA. So the CCTS has a mission. It has, the mission involves populations in the Deep South that have special, that are impacted disproportionately by health problems. We also are interested in the lifespan, science across the lifespan, beginning from prenatal to postnatal to geriatric subjects. You'll have to show you're eligible. And that's easy because for many of you, you're probably early stage investigators. And that's what the program is geared towards. If you're a later stage investigator, don't despair. The program is available to later stage investigators, especially those individuals who are transitioning from one type of science to another. Sometimes that's called transitioning to translation. If you are a basic scientist working at the bench, you have an idea you want to move into animal models or beyond, it's still worth applying to the program. I will say the application is a two-part application. There's a pre-submission, which is due August 15th is the pre-application. And in that, there'll be certain things you have to tell us about, like why you're eligible and how your application is responsive to the mission of the CCTS. Those pre-applications will be looked at by a committee. The second phase of the process, the full application, you'll be invited to submit if your pre-application is judged to be responsive to the RFA and to be really, really good science, by the way. So the full application due date is August 31st.
October.
Sorry, October, yeah. And then the scientific merit review begins in November. So one thing about the CCTS pilots, There are multiple stages of review. There's a local review, but there's also a review at NIH. And there'll be a place for you to sign that says you understand that. That's important to remember. Your review doesn't just stay local. There'll be other people looking at it. Anyway, it's an incredibly important program. The people who apply for it and are successful with the pilot program also have to have panels. Does everybody know the expression Tanzstoffel? There ain't no such thing as a free lunch. So if you're going to apply for the program, there will be things you have to do. There'll be certain panels you have to go through, certain consults, including biostats and epidemiology research design, and one or two others, depending upon your subject area. But all in all, it's been a very successful program for our awardees. The pilot program coupled with the panels program is pretty hard to beat. Now I'm going to have the pleasure of introducing one of our colleagues, Adam Monday, who's been successful with our pilot program and a number of awards post-pilot. So Adam, come on up.
Okay, so I'd like to also thank for the opportunity to present today. And I have to say it's kind of intimidating trying to prepare a talk of this nature. I'm very used to giving scientific talks, but trying to give an advice talk is quite a bit different wheelhouse for me. So the approach I took was to lead by example, and it's going to look like a very heavy scientific talk. But what I want you to do while I'm speaking is think about what are parallels in whatever projects you may be working on in which you can take advantage of the unseen. And what I mean by that is most of my success has actually been from being wrong. And it's really finding that null hypothesis and not being afraid to follow it and not being so wed to your hypothesis that you won't look beyond it and actually truly interpret the data. And what I mean by that is usually when you come up with a hypothesis, it's the logical conclusion, right? So you want to go ahead with that and you do the experiments, you see the responses like, well, duh, I could have predicted that by the literature. But when you're wrong, then the challenge is trying to figure it out. So that is what I hope to accomplish in the next 10 to 15 minutes. And please be interactive. I was told this was kind of more like a panel, so if you want to interrupt me, please do, and I will expand on that. So the take-home message is follow the data. Don't be wedded to your hypothesis. And I'm going to tell you a little bit about what we study in the laboratory, why we study it, and then give you examples of how some of the roadblocks in my process throughout the pilot grant actually led to a number of funded projects, awards, and publications. So my laboratory studies diabetes and obesity, and for those who don't know what's going on around you, since the mid-'80s, the CDC's been trying to determine what's going on with obesity. They've been tracking it. And over the subsequent 25 years, you can see a pretty stark accumulation of diabetes, particularly in the Southeast where we're located. This is associated with physical inactivity and diabetes and eventually heart failure. And one of my reasons for starting my laboratory here at UAB was because right here in the center of the problem, Alabama, not one of the best accolades to have, is always in the top 3 for either obesity or diabetes. So that's what we study, and what we're trying to determine is how diabetes affects heart disease. But I'm a PhD, and up until relatively recently, I was most comfortable with mice and cells. So one of the things I wanted to accomplish by working with the CCTS was to branch out and get into that scary field of translational research and actually kind of deal with some human samples. And I will just pause to note that as far as some of the panels that were mentioned earlier, I'm a cheerleader of the CCTS. I've participated both as a recipient and on the panel for things like panels done quickly, for a resubmission of an R01 that was subsequently funded, as well as the Mentoring Academy, which is CCTS also sponsors, which is really good for junior investigators such as myself and trying to manage the team as you're wading through these panels. So the question that our laboratory focuses on is what is the connection between nutrient excess and heart failure? And the title, for full disclosure, of my CCTS pilot grant was Human Blood DNA Methylation and RNA Transcript Signatures to Define Diabetic Cardiac Feed Subtypes. Okay, now the keywords there being human blood, and I'll get to that at the end of the talk. But they decided this was a worthwhile pilot and gave me funding to start looking at some of this analysis. And the reason why we were interested in this is because we were trying to figure out why has diabetes and heart failure proceeded so quickly in this country? And one of the fields that was actually alluded to in the last talk is that of epigenetics. And basically what epigenetics is all these environmental factors and how they influence gene expression. This can be stuff you're doing, like listening to me talk right now, having a beer or a glass of wine, or things that your parents and maybe even your grandparents did. So that's the field we study. And what epigenetics is it's the non-coding RNA that we heard about in the previous project. It's histone modifications, which I won't talk about, and it's DNA methylation. And this is what we look at in the lab. So what the pilot grant was to do was to look in the heart of these diabetic patients to see if we could identify one of these epigenetic signatures that might explain why gene expression changes lead to heart failure in diabetic patients. So how do you go about getting human heart? Well, you talk to the surgeons. And this was one of the useful things about getting into a translational project, because one of the things my committee, when I first met with the CCTS panel, strongly encouraged was to actually go and talk to the surgeons, which bridging this gap between PhDs and MDs. And it was very useful because up until that point, I would do a lot of freezer diving, so there's a number of different tissue banks. And this is a useful resource, but I think sometimes you take it for granted. So if you're going to get into this translational research and you're on the PhD side, go and talk to those MDs and actually see what's involved. So in my case, to get human heart, I teamed up with the heart failure surgical team here at UAB. And what they do is in these end-stage heart failure patients, they can insert this little pump called the left ventricular assist device. And in doing so, they get a little piece of that heart out, and then that piece is what I analyze for both gene expression and DNA methylation. But the most eye-opening thing in actually getting into a translational project was when they invited me to go to their surgical consult meeting for some of these patients. Because within the pilot grant, I was going to have to get IRB approval to start consenting some of these patients to get their blood paired up with the tissue. And the thing that blew me away was it wasn't 5 people in the room, it wasn't a dozen people in the room, it was close to 3 dozen people in the room, all just discussing the surgeries for that week. Because in order to do a surgery like this, you need pre-surgery, during surgery, post-surgery. So it really gave me an appreciation of what translational science actually means. So what did I do with those pieces once I realized how precious they actually were? Well, I broke them down into diabetic and non-diabetic and selected those to start analysis. And this is just briefly showing that they're all heart failure. Half of them had diabetes, half of them didn't, and a few other parameters that'll come to be very important in a moment, and did the analysis. And what this red and green is just looking at DNA methylation. The green is less DNA methylation, the red is more DNA methylation, and we could see a distinct pattern. So our hypothesis was supported. But what does this mean, and where do we go with this as far as taking this pilot to funded projects? So what Mark Pepin, the MD PhD student in my lab, did was he designed a bioinformatic pipeline for this project to take those methylation changes and compare them to gene expression changes. And we only found 17 genes that were consistent with the hypothesis that more methylation or less methylation was inversely associated with gene expression. So what did we do with that modest finding? Well, these are the genes for those who care about this type of thing. But as far as it relates to taking a pilot to a project, I'm going to highlight a few things that we did with this simple data set. And in thinking about your own projects, think about where there might be overlap in different things. So one of the things we first noticed was this gene BDH1, which was one of the 2 genes that was methylated and decreased, was also that way in humans. Now, fortunately, we'd already identified this pathway through a metabolomic supplement with Steve Barnes, who was mentioned earlier. So by collaborating with other people in the university, we were able to take this to a now funded American Heart Association fellowship. Mark Pepin, who was leading this analysis, on the other end of the spectrum, identified GAD45B, which we had completely overlooked in our mouse work because it's only studied in the brain. And it happens that Jeremy Day, also here at UAB, had all the resources available to study this gene, which we then turned into an F30, which Mark then subsequently got funded. Finally, my most recent student, analyzing this same data set with Mark's help, identified a transcription factor that was regulating a whole branch of these genes, which has now been turned into a T32. So one pilot grant has so far resulted in 3 trainees being successfully funded, and we've been really happy with the success. But where does the panels fit in, and where has it changed the trajectory or maybe added an extra leg to my flight? Well, one of the questions I was asked by my first panel update was, what about the underlying coronary artery disease? I'd had the blinders on and I was only focused on diabetes. So we went back and looked at ischemic status, which is one of the effects in heart disease associated with diabetes. And what we found kind of surprised me. This was our analysis of those same humans looking at ischemic status, which was infinitely more robust than any of the mouse work I'd ever done. And really, it was the fear of branching into a new area that had prevented me to even think of this in my first place, but the panel suggestion, we looked at it, and it was very robust. And this project in particular was actually accepted earlier this month for publication in laboratory investigation. And it had to do with other collaboration. So taking this finding in an area that you might not be comfortable in and say, where's a collaborator at my institute? Where's there a collaborator in the country that I can meet with? Because it turns out in this project, one of the things that we try to do, because we don't study ischemia, is how can we take these clinical observations and find a model? So the NIH has rightly mandated that all these large omics data sets get submitted to something like GEO, or Gene Expression Omnibus. So what Mark did when we identified a new gene that we didn't have a mouse model to do is go and find previously published data sets, which is something any of you can do, and started looking through ischemic models, is this also regulated? What we also did through that was identify this methyltransferase, EZH2, which turns out that Suri Varambali here at UAB has been studying in prostate cancer for the last 10 years, and he had all the reagents available for studying that. So we reached out yet again to another collaboration and partnership, and that was what helped get this published on its resubmission. Furthermore, this project was presented at the Basic Cardiovascular session of the American Heart Association last year, for which I got the Outstanding Young Investigator Award. So one data set, 4 very positive outcomes. So what I want to end with is this idea of getting outside your comfort zone. And we took this data and we had done target analysis either by the original hypothesis of diabetes, which led to the 3 trainee grants, by the panel suggested of looking at ischemia and resulting in this publication, to an unbiased approach. So we took the data and just said, of these methylation changes, using a principal components analysis, what hypothesis might be there that we didn't even think to look at? And when we looked at the data there, it grouped into 3 very obvious groupings. And we're like, well, that's funny, what's going on here? And it had to do with one of the variables that I hadn't considered up to this point, and that was race. Being in the Southeast, race disparities in health outcomes is a very real problem, something that I had not been aware of, or at least not focused on in my own research. And it turned in that you really have to pay attention to those other opportunities that come about in the planes, trains, and automobiles thing. And at the same time that I got that principal components analysis, Dean Vickers announced this Center for Healthy African American Men through Partnerships pilot grant. And I went a little too fast there. And what we did with that is then use this preliminary data for another pilot grant. So we took our original 11 patients, expanded it to 32 patients, and saw that just like the other changes in diabetes or ischemia, there was a racial signature of which we can now compare diabetes in African Americans versus diabetes in Caucasians. And we've identified 2 very distinct pathways, one being more metabolic in the Caucasians and one being more inflammatory in the African Americans. And we're hoping to submit this study for work very soon. So I know that was more of a scientific talk, but I think really, in addition to the scientific conclusion of epigenetics being important to study, is the idea that when you get your pilot data, first of all, submit to them. In my 2nd to 3rd years here at UAB, I submitted no less than 12 grants, okay? So you gotta write, you gotta submit. You don't get them all. But if you can get a data set, look to see not only what supports your hypothesis, but what you might have missed in that data to go on and on and on, and just follow where the results lead and not necessarily what you think the hypothesis needs to be. So the little caveat of all this is, what was the title of my pilot study? It was the epigenetics of blood. So some of the roadblocks along the way were getting through IRB and learning how to actually consent patients. We have that all smoothed out with the help of the CCTS, but we do not have that data analyzed yet. Hopefully it'll come in a future talk. But all of this success has come completely independent of what I was initially targeted to do because of roadblocks. But those roadblocks, instead of just throwing my hands up in there and saying, I'm going to wait till that's done, we took the data, analyzed it by the advice of the panels, and looked to see other things that we might utilize those findings for. And that has really been where the success has been. So as mentioned, that everything's a team effort. I model my laboratory after that. I mean, almost 90% of my work is collaborative in nature. Only about 10% is entirely included within my own lab. So follow those things. If you have a new novel target, don't be afraid to find out who the expert is. Most people are willing to help, and then success only begets more success, and just kind of keep that steam moving as you go forward. So apply to those pilot grants, and once you start getting data, don't be discouraged if it doesn't match your original hypothesis, and just follow where it leads you. With that, I'll take any questions.
You did with the males over there. Have you run into this problem of, hey, sex differences and I would have thought that, hey, where's your female data? Heart disease kills, looks like leading cause of women, right? Or whatever. With that, how do you address that?
So great question. As I just mentioned, I applied to 12 pilot grants. The sex one was not funded. It made it through the first 3 rounds and did not get funded. But so that data I showed you, that initial combined methylation and transcriptomics, that's about $40,000. So to be able to also do it in females, I just needed the additional money. So it's a great question. I'm just looking for the money to do it. That'll hopefully be the next pilot.
I have a question. Thank you for your talks. And my question is more like generally about CCTS as a pilot project, because when I hear about your project is very fit into the mission of CCTS, like reducing discrimination in race or other things. But my research is like generally cancer, particularly pancreatic cancer, and I had really hard time to rationalize why it fit into the mission of CCTS. So I did my best, but the reviewer says that, hey, that is not strong enough. I mean, we are more focusing on the discrimination between the black, communities and other things. So I wonder whether CCTS really focusing on the racial discriminations and all those things, and if the project is a couple of steps away from the missions, then I wonder how I will be able to address this to overcome it.
So my advice on that is grantsmanship. I mean, at the end of the day, I'm a transcriptional biologist, which at its face value is as basic as it becomes. So it's how you interpret your findings or the specific basic question you're asking. And I mean, by no means was the way I presented this story today the actual order of events. There were different hiccups along the way of, okay, so I want to study DNA methylation. How can this be relevant to the appropriate funding situation? Or for example, like with the CHAMPS grant, some of it's being lucky, being in the right place at the right time, but the other one is not being afraid to reinterpret what you're doing in your lab. So you said it's too far away from the mission. Well, go backwards then. So if this is the mission statement, how might your project fit in with it? And then find that thread, whatever it is, and work to build that up either through collaboration or by getting more panel advice. Does that kind of answer your question, or?
What do you think that Kimberly should advise on?
Well, and hang on just a second, because you had a comment.
Yeah, I was just going to add, as far as my experience, so I had the same question as far as applying for it, because again, I'm working with cystic fibrosis, which is largely a Caucasian disease. And so I think to his point that I had to find what aspect of CF corresponded with the potential aims of the CCTS. So that was one reason why I very much tried to connect with the partner network investigator Mobile to make that, a really strength that UAB is partnering with USA. And then I also framed it that, this is a pediatric disease. So basically really focusing on, and the pediatric subtypes was one of the defined population. And then as far as health disparities, instead of looking at racial health disparities, I was just talking about life expectancy. And this is a subgroup of, kids whose life expectancy is different. And, so that was just different ways to frame it so that not a clearly, socio-environmental based disease had a receptive audience.
And I guess the other way I'd answer that question, and it was mentioned in one of the final slides of the previous talk, was there are other foundations. So the CCTS Pilot Award might not be your vehicle, but it could help fine-tune wherever you are applying. So like Gilead has a pretty wide range of projects that it will fund, but if you get together that pilot award for submission, but use the CCTS resources to fine-tune it either through consulting with, one of the things I forgot to mention was using the statistical analysis team, that's the Baird, because that actually helped finalize that publication, because one of the things we had overlooked in doing the combined analysis was within patients, but the statistician in that consult said, go back and do that, and became a figure in the resubmission of the paper. So you can use the CCTS to still fine-tune grants in other sources that might not fit within the UAB mission statement.
So if I could just add a couple of comments to that. I think when you think about especially panels and not only the feedback from colleagues, all of our colleagues within our community, but also the methodologic expertise, that we hope is an entree to our working together, not just for CCTS funding, but as you point out, Adam, funding at other voluntary health agencies, various federal mechanisms and so on. And part of our goal, even for those who might submit to pilot awardees, it is the strategy where, well, if you don't get funded, that's too bad, just don't bother us any further. We'll continue to work with you to figure out how to reposition your proposal for other opportunities that might be outside, either within UAB or outside UAB. So I would encourage you to come to the panels, to do that as a mechanism for refining where your science is going. And part of that is the strategy of where to take it for funding. We'd love to be able to fund every idea. That's a little bit beyond our capability. But when we can't do it specifically with a CCTS, our second goal is to find another venue for you. So please come to the panels and we'll work with you to develop your science.